Good morning, chemistry students. Here are the corrections for ChemQuest 24 ionic bonding and ChemQuest 25 advanced ionic bonding. So ChemQuest 24 ionic bonding information naming ions. To write an ion, you write the symbol of the atom and put the charge in the upper right corner. Consider the following examples: Al3+, O -2, Mg2+. You should verify that each of the charges is correct. So how do we verify that each of the charges is correct? Remember, these are going to choose to become like a noble gas and have a noble gas electron configuration. So aluminum, right, has 3 valence electrons. So it could lose 3 or gain 5 to have the octet or have the 8 that the noble gases have. Remember, it's always going to do whatever's easiest, so it's going to lose 3. So when aluminum loses 3 electrons, it's going to be aluminum with a +3 charge. For oxygen, oxygen is in group 6A, which means it has 6 valence electrons. So it could lose 6 or gain 2 to get its octet. Again, it's always going to do whatever's smaller, so it's going to gain 2. So oxygen is going to get 2 extra negative charges, giving it a charge of -2. For magnesium, magnesium is in group 2A, so it has 2 valence electrons. So its choices are to lose 2 or gain 6. Again, it's always going to do whatever's easiest, so that's lose 2. So magnesium is going to have a charge of +2. Positive and negative ions are named differently. Positive ions retain the same name as the parent atom. For example, Al3+ is called the aluminum ion, and Mg2+ is called the magnesium ion. Negative ions are named a little differently. For negative ions, you change the ending of the name to "ide." Therefore, O -2 is named oxide, and P -3 is named phosphide. So again, what they're saying is our positive ions, it's the element name plus the word ion. For our negative ions, we're going to take the element name. It's going to lose its ending. And then you're going to add "ide." So question 1. Sulfur forms a negatively charged ion. Is the name of the ion sulfur or sulfide? Explain why. So because it's a negatively charged ion, it's going to do that element name minus its ending plus "ide." So sulfur is going to be called sulfide when it becomes a negatively charged ion. Sulfide because negative ions end in "ide. Number 2, sodium forms a positive ion. Is the name of the ion sodium or sodide? Explain why. Well, again, positive ions, it's the element name plus the word ion. So it is sodium ion. And I really don't like this choice here because it should have the word ion after it. So sodium ion, because the names of positive ions are the same as the name of the atom with the word ion behind it. Question number 3. Write the symbol, including the charge, and the name for each of the ions for each of the following. The first is done for you. So again, to kind of talk through this example, right? For chlorine, when I find chlorine on my periodic table, it is in group 7A, so it has 7 valence electrons. So its choices would be to lose those 7 to be like neon, or to gain 1 to be like argon. It's going to do whatever smaller, so it's going to gain 1. So chlorine is going to get a -1 charge. And because it's negatively charged, its name as an ion is chloride. So, taking a look at calcium. Calcium is in group 2A, so it has 2 valence electrons. So its choices would be it can lose those 2, or it can gain 6 to get the octet, like the noble gases have, right? If calcium loses 2, it's going to be like argon. If it gains 6, it's going to be like krypton. It's going to do whatever smaller, so it's going to lose its 2. So that means we're going to have calcium with a +2 charge. And because it's positively charged, its name is calcium ion. So for nitrogen, nitrogen is in group 5A, which means it has 5 valence electrons. So it can lose those 5 to be like helium, or it can gain 3 to be like neon. It's going to do whatever smaller, so it's going to gain 3. So we're going to have nitrogen with a -3 charge. And because it's negatively charged, it's going to lose its ending and get an "ide", so it's going to be nitride. Potassium. Potassium's in group 1A, so it has 1 valence electron. So it can either lose that 1 or gain 7 to be like a noble gas, right? If it loses 1, it's going to be like argon. If it gains 7, it's going to be like krypton. It's going to lose its 1 because that's the smaller number. So it's K with a +1 charge. And its name is potassium ion. Next we have sulfur. Sulfur is in group 6A, so it has 6 valence electrons. So its choices would be to lose those 6 to be like neon, or to gain 2 to be like argon. It's going to gain 2 because that's the smaller number. So it's going to be sulfur with a -2 charge. Because it has a -2 charge, it's going to have that "ide" ending, so it is sulfide. Boron is in group 3A, so it has 3 valence electrons. So it can lose those 3 to be like helium, or it can gain 5 to be like neon. It's going to lose 3 because that's the smaller number, so it's going to be boron with a +3 charge. Because it's positively charged, it's going to be boron ion. And lastly, we have phosphorus, which is in group 5A, so it has 5 valence electrons. So its choices would be to lose those 5 or gain 3. It's going to gain 3, so it's going to be a phosphorus with a -3 charge. And so its name is going to be phosphide. Information, ionic bonding and formulas. There are two ways in which atoms can bond to each other and form a compound. The means of bonding that we will consider now is called ionic bonding. Ionic bonding occurs between a metal and a nonmetal. As you know, opposite charges attract. Ionic bonding is when two ions of opposite charge attract and bond to each other, forming an ionic compound. Consider the following examples of formulas for ionic compounds. 1 sodium ion and 1 chloride ion bond to make sodium chloride. 1 magnesium ion and 2 fluoride ions bond to make magnesium fluoride. 3 calcium ions and 2 nitride ions form to make calcium nitride. 1 aluminum ion and 1 nitride ion bond to make aluminum nitride. The small numbers at the bottom right of each symbol in a formula are called subscripts. Subscripts tell us how many of each type of atom are present. For example, in the formula Mg3N2, there are 3 magnesium ions and 2 nitride ions. Question 4. Consider the formula NaCl in the above example. It tells us that 1 sodium ion is bonded with 1 chloride ion. What is the overall charge for sodium chloride? Is it positive, negative, or neutral? So we know that sodium ion has a +1 charge and there's only one of them. Right, so that gives me a total positive charge of +1. I have a chloride ion with a -1 charge, and there's only one of them, and I know there's only one because there's no subscript written, and when there's no subscript, it's assumed to be 1. That's -1. So +1 minus 1 is 0. So is it positive, negative, or neutral? It is neutral. Number 5, consider magnesium fluoride. Letter A, what is the charge on a magnesium ion? So again, magnesium is in group 2A, so it has 2 valence electrons, so it could lose 2 or gain 6, right? It's going to lose 2, so it's going to have a charge of +2. Letter B, what is the charge on a fluoride ion? Okay, fluoride is in group 7A, so it has 7 valence electrons. So it could lose those 7, or it could gain 1. It's going to gain 1, so it's going to have a charge of -1. What is the overall charge on magnesium fluoride? Note the formula magnesium fluoride tells us that 1 magnesium ion bonds with 2 fluoride ions. So magnesium ion times 1 gives me a total charge of +2. But I'm going to have 2 of these fluorides according to the formula, which gives me a charge of -2. So the overall charge is 0. It's neutral again. Number 6, given your answer to question 4 and 5C, what do you think is the overall charge on any ionic compound? Right, so we just said that this compound was neutral, and we said that this compound was neutral. So what has to be true of all ionic compounds? They must be neutral. So we could kind of say that the total positive charge has to equal the total negative charge. right? And we saw that here. We had our total positive charge was +2, our total negative charge was -2, so they're equal to each other. Number 7, calcium nitride is written like this, Ca3N2. What is the charge on one calcium ion? So calcium, again, is in group 2A, so it has 2 valence electrons. So it can lose those 2, or it could gain 6. It's going to lose 2, so it's going to have a charge of +2. What is the charge on one nitride ion? Nitrogen is nitride, and it's in group 5A, so it has 5 valence electrons. So it could lose those 5, or it could gain 3. It's going to gain 3, so it's going to have a charge of -3. In the formula Ca3N2, there are 3 calcium ions. What is the total charge on 3 calcium ions? So if I have Ca plus 2 times 3 of them, that gives me a total charge of +6. In the formula Ca3N2, there are 2 nitride ions. What is the total charge on 2 nitride? So I have N with a -3, and I'm going to have 2 of those, which gives me a total charge of -6. Number E, or letter E. Why do you think it must be written that Ca3N2 and not something like CaN2 or Ca2N3? In other words, why do exactly 3 calcium ions bond with exactly 2 nitride ions? Hint, think about what your answers to part C and D equal when they're added together. Right? What happens when I add these together? I get no charge and I am neutral. Okay, so again, the reason that it has to be Ca3N2 is because this is an ionic compound, and an ionic compound must have no charge overall. The only way for that to happen is if you have 3 calcium ions combined with 2 nitride ions. The person who wrote this explained it this way: so that the compound will be neutral. Number 8. Why do you think sodium nitride is written Na3N instead of Na2N? So let's look at sodium as an ion first. Right? Sodium's in group 1A. It has 1 valence electrons. So it could lose 1 or gain 7. It's going to lose 1, so it has a charge of +1. For nitrogen, it's in group 5A, so it has 5 valence electrons, so it can lose those 5, or it can gain 3, because it's trying always to have an octet like the noble gases. It's going to gain 3, so it's going to have a charge of -3. So add A plus 1 times 3 gives me a charge of +3. N, -3 times just one of them gives me a charge of -3. I have a charge of 0. If my formula was Na plus 1 times 2, I would have a charge of +2. N, -3 times 1 gives me a charge of -3. Notice I would have a charge of -1 here. So this is not a neutral compound. This is a neutral compound. So the reason that sodium nitride has to be written Na3N is because it's an ionic compound, and overall it must be neutral. It cannot have a charge, so it has to be written as Na3N. So Na3N has a charge of 0. Number 9. The chemical the formula Ca3N2 can never be written as N2Ca3. To find out why, take note of each of the 4 example formulas given above. Letter A, what do the first ions named all have in common? Right? What do we notice about the first one? Here's the first one. Here's the first one. Here's the first one. Here's the first one. What do we notice about all of those first ones? Okay. Right? They have a positive charge. What do the second ions all have in common? So here was my second ion. Here's my second ion. Here's my second ion. Here's my second ion. Again, what do I notice about all of them? They all are negatively charged. So, now, why can't Ca3N2 ever be written like N2Ca3? Positive ions are always written first in a chemical formula. Okay, so the positively charged ion is always written first. Number 10. There are 2 rules to follow when writing formulas for ionic compounds. One has to do with charges, see questions 4 and 5, and the other has to do with which atom to write first and which one to write second, see question 6. What are these 2 rules? So if we look back at questions 4 and 5, like it tells us to, right? Number 5, we had a neutral compound. Number 4, we had a neutral compound, right? We said that compounds have to be neutral. So one of the rules, okay, is that the overall charge on the compound must be 0 or neutral. Right? So again, this is this idea that our total positive charge has to equal our total negative charge. All right, question 6. Okay. And kind of also, right? That's that. And then again, it was which ones were we writing first and which one were we writing second. Okay. The positive ion is always written first. In our chemical formula. So these are our 2 rules that we have to follow. Overall, our charge has to be 0, and we always write the positive ion first for ionic compounds. Number 11, what is wrong with the following formulas? So when we look at Al2S, so aluminum is in group 3A. It has 3 valence electrons. So it can lose 3 or gain 5. It's going to lose 3, so it's going to have a charge of plus 3. Sulfur is in group 6A, so it has 6 valence electrons. So it can lose those 6 or gain 2. It's going to gain 2, so it's going to have a charge of negative 2. And according to this formula, there are 2 of these, and there is 1 of these. So I have a plus 6 charge. I have a negative 2 charge, which gives me a charge of plus 4. So what's wrong with this formula? Of these 2 rules, right, the positive ion is written first, so that's okay. But the overall charge on the compound must be 0. And this would have an overall charge of plus 4. So, kind of on a side note, right, let's figure out what the formula would have to be. If these each have a positive 3 charge, and these each have a negative 2 charge, the charge I could get for both of them would be 6. I would need 2 of these and 3 of these, right? So that would give me a plus 6 and a negative 6, which would give me a 0. So my formula should be Al2S3. All right, we look at phosphorus and nitride, or sodium, right? So we have phosphorus, which is in group 5A and has 5 valence electrons, so it can lose its 5 or gain 3. It's going to gain 3. It has a charge of negative 3. Sodium is in group 1A. It has 1 valence electron, can lose 1 or gain 7. It's going to lose 1, so it has a charge of plus 1. This says that there is 1 of these and 3 of these. So overall I'm 0. So what's the problem with this one? Well, notice, right, phosphorus is written first and it has a negative charge. So what's wrong with this formula is that phosphorus is written first. The correct formula would be Na3P. So the ratio is right because overall we have a charge of 0, but the sodium ion would need to be written first. Okay, magnesium, okay, is in group 2A, so it has 2 valence electrons, so it could lose 2 or gain 6. It's going to lose 2, so it has a charge of positive 2. Okay. Sulfur, okay, is in group 6A. It has 6 valence electrons. It could lose 6, or it could gain 2. It's going to gain 2, negative 2 charge. Okay. And this says there's 1 of them, so that gives me a positive 2 charge. This says there's 2 of them, which gives me a negative 4 charge. So I have a negative 2 charge overall. So this is okay because the magnesium one is written first, but the problem here is they're not neutral. So what ratio would I need to combine these in? Well, magnesium is positive 2 and sulfur is negative 2. So I could just combine them in a 1-to-1 ratio, right? And that's going to give me a positive 2 and a negative 2, which gives me a 0. So this should have been written just MgS. Information about writing formulas. Let's say you need to write the formula for the compound formed by magnesium and chlorine. Follow the 2 steps below to write the formulas. Step 1. Write the charges for each of the ions. The positive ion should be written first. So Mg plus 2 and Cl negative 1. Step 2. Write the positive ion first and make sure the charges are equal. You will need 2 chloride ions to cancel out 1 magnesium ion, so MgCl2. Note, many times you can use the crisscross method. Write the ions next to each other and, like in step 1 above, and then crisscross the charges like below. So notice it's just the charge itself, it's not, or the number for the charge, not the sign. So you move the 2 here, but not the positive sign. You move the 1 here, but not the negative sign, and so it becomes MgCl2. So this is a quicker way to figure out chemical formulas. Number 12, write the formula and name for the compound that forms when the following atoms form ionic compounds. The first is done for you. So how did we get to lithium and chlorine being that? Lithium is in group 1A, so it has a charge of +1 because it loses that 1 valence electron. Chlorine is in group 7A, so it has a charge of -1. I crisscross down my 1s, and I don't write 1s, so it's just LiCl. In terms of naming it, it's lithium ion and chloride, so it becomes lithium chloride. So we kind of drop the word ion when we write it together as a compound. So if we look at letter B, we have barium and sulfur. Barium is in group 2A, so it has 2 valence electrons, so it's going to lose those 2. Sulfur is in group 6A, so it's going to gain 2 electrons. So I crisscross down my 2s. But that's not the lowest whole number ratio, and so because it's not the lowest whole number ratio, my formula is just going to be BAS. And then naming it, this is barium ion and sulfide, so this is barium sulfide. Magnesium and iodine. Magnesium is in group 2A, so it's going to lose those 2 valence electrons. Iodine is in group 7A, so it's going to gain 1 valence electron. So I crisscross down. I don't write my 1s, so my formula is MgI2. And this is magnesium ion and iodide, so its name is magnesium iodide. Oxygen and aluminum. Oxygen is in group 6A, so it could either lose 6 or gain 2. It's going to gain 2, so it has a -2 charge, which means I need to write it second in my formula. Aluminum is in group 3A, so it has 3 valence electrons, or gain 5. It's going to lose those 3, so it's going to have a +3 charge. I crisscross down just my numbers, and I have Al2O3. Aluminum becomes aluminum ion, oxygen becomes oxide, so the name of this compound is aluminum oxide. So calcium and phosphorus. Calcium's in group 2A, so it can lose 2 or gain 6. It's going to lose 2, so it has a charge of +2. Phosphorus is in group 5A, so it can lose 5 or gain 3. It's going to gain 3. I crisscross down my numbers. So I have Ca3P2. Calcium becomes calcium ion. Phosphorus becomes phosphide. So this compound is calcium phosphide. So notice to name them, I'm just combining the name of the cation and the anion, dropping the word ion. So sodium and sulfur, sodium's in group 1A, so it can lose 1 or gain 7. It's going to lose 1. Sulfur's in group 6A, so it can lose 6 or gain 2. It's going to gain 2. I crisscross down my numbers. I don't write ones, so it's Na2S. Na, sodium becomes sodium ion, sulfur becomes sulfide, so this is sodium sulfide. Number 13. Given the following compounds, determine the charge on the unknown ion X. The first one is done for you. So for this one, you're going to kind of look at the negatively charged ion, right? I don't know what X is, so I look at sulfur. Sulfur's in group 6A, so its choices would be it could lose those 6 or gain 2. It's going to gain 2, so it has a charge of -2. There's one of them. So -2 times 1 gives me a -2 charge. So that means, right, X, there's 2 of them, so that -2 charge is divided by 2, so X has a charge of +1. So looking at the second one, MgX, I don't know what X's charge is, so I look at magnesium. Magnesium is in group 2A, so it can lose 2 or gain 6. It's going to lose 2, so it has a charge of -2. There's only one of them because there's no subscript, so this has a +2 charge. And there's only one X, so X must have a charge of -2 to get us to be 0. So X's charge is -2. This third one here, phosphorus is in group 5A, so it can lose 5 or gain 3. It's going to gain 3, so phosphorus has a charge of -3. There are 2 of them, so that's a total of a -6 charge. Now X, there's 3 of them, so that -6 charge is going to be divided by 3 of them. So each X is going to be have a positive charge of 2 because it has to cancel that out, right? So if X has a charge of +2 and there are 3 of them, that gives me a +6 charge to give me a 0 charge overall. So X has a charge of +2. This final one, right? Nitrogen is in group 5A, so it could lose 5 or gain 3. It's going to gain 3, so nitrogen has a charge of -3. There's only one of them, so that gives me a total charge of -3. Now, there are 3 of these X's, so I'm going to divide by 3, right? That means that each X has a +1 charge. So if X has a +1, and there are 3 of them, that gives me a +3 charge, and I get an overall neutral charge. So X has a charge of +1. ChemQuest 25, Advanced Ionic Bonding. Information, polyatomic ions. The word polyatomic means many atoms. A polyatomic ion, therefore, is an ion that is made of more than one atom. An example of a polyatomic ion is the sulfate ion, SO4-2. Sulfate is composed of 1 sulfur atom and 4 oxygen atoms, and overall sulfate has a -2 charge. Some polyatomic ions are listed below. Many polyatomic ions end in -ate. Acetate, carbonate, chlorate, nitrate, phosphate, sulfate. Some other polyatomic ions, ammonium, cyanide, hydroxide. Number 1. What do all of the polyatomic ions that have the suffix ate have in common? I.e., what atom exists in all of the polyatomic ions that end in ate? So notice acetate has, right, I'm looking for what element are in all of these, and the element that are in all of these is oxygen, okay? So they all contain oxygen. Which two atoms do you think compose the polyatomic ion called silicate, right? So if you look back here, right, sulfate is sulfur and oxygen. Phosphate is phosphorus and oxygen. Nitrate is nitrogen and oxygen. Chlorate is chlorine and oxygen. Carbonate is carbon and oxygen. So what do you think silicate is going to be? Well, silicate is going to contain silicon and oxygen. Number 3, what is the difference between calcium nitride and calcium nitrate? Right, remember nitride, that is our nitrogen as an ion. Nitrate, right, is going to be nitrogen and oxygen together as an ion. So calcium nitrate has oxygen, but calcium nitride does not. Information. Writing formulas with polyatomic ions. First of all, you must remember that you can never change the formula for a polyatomic ion. Sulfate is always SO4 negative 2 and never S2O8 negative 4 or something else. Following are some examples of chemical formulas that contain polyatomic ions. Sodium sulfate, Na2SO4. Step 1, write each ion and each charge positive first, right? So reminding you of those two rules. And one of the two rules with ionic compounds is you always write the positively charged ion first. Step 2, crisscross to balance the charges, right? So remember we did this on that chem quest we just finished going over, that we crisscross down just the numbers, okay, not the signs. Here's what you get, Na2SO4. Add parentheses if you want to. Typically, we don't add parentheses if we're crisscrossing down a 1. Magnesium nitrate. Step 1, write each ion and each charge positive first. Step 2, crisscross to balance the charges. So again, I have a 2 and a 1. Now, here's what you get, MgNO3, 2. Which means you must add parentheses. So you have to add parentheses if you need more than one polyatomic ion. Consider calcium hydroxide. Calcium has a positive 2 charge and hydroxide has a negative 1 charge. We need 2 hydroxide ions to combine with 1 calcium ion so that the overall charge ends up being 0. We write calcium hydroxide like Ca parentheses OH outside our parentheses 2. Following are some more examples: potassium acetate, barium phosphate, magnesium nitrate, calcium carbonate. In the expression Mg parentheses Cn2, there is 1 magnesium atom, 2 carbon atoms, and 2 nitrogen atoms. So this subscript applies to both of the atoms inside those parentheses. Number 5, in the expression MgCN2, there is 1 magnesium atom, 1 carbon atom, and 2 nitrogen atoms. Number 6, as mentioned above, calcium hydroxide is written like CaOH in parentheses 2. Why can't it be written like CaOH2? Right? This formula has 1 calcium, 2 oxygens, and 2 hydrogens. This formula has 1 calcium, 1 oxygen, and 2 hydrogens. These are not the same, right? There's not the same number of atoms, okay? And so you can't write the formula this way because you don't have the same number of atoms. There needs to be 2 hydroxide ions, OH negative 1, and not merely 2 hydrogens. Number 7. As mentioned above, magnesium nitrate is written as MgNO3 in parentheses 2. Why can't it be written like MgNO32? Because again, this formula says we have 1 magnesium, 2 nitrogens, and 6 oxygens because of the 3 times the 2. Over here, I have 1 magnesium, 1 nitrogen, and 32 oxygens. Again, they are not the same. MgNO32 looks like 32 oxygens rather than 2 nitrates. Number 8. Name the following compounds. Each includes at least 1 polyatomic ion. We're still going to combine the name of our cation and our anion, dropping the word ion. So sodium is sodium ion. PO4 on our first page is phosphate. So the name of this compound is sodium phosphate. NH4 is on our first page of this, and it's called ammonium. SO4 is on our first page, it's sulfate. So the name of this compound is ammonium sulfate. Letter C, Mg is magnesium. C2H3O2 is on our first page and it's acetate. So this is magnesium acetate. Again, NH4 is on our first page, that's ammonium. S is sulfur. As an ion, it becomes sulfide, remember, because it gets that IDE ending. So this is ammonium sulfide. Ca, that's calcium, and it becomes calcium ion. CO3 is on the first page, that's carbonate. So this is calcium carbonate. Ba, that's barium ion. NO3 is on our first page, that's nitrate. So this is barium nitrate. Number 9. Write formulas for the following ionic compounds. Note that each includes a polyatomic ion. So lithium is in group 1A, so it loses its 1 valence electron to get a +1 charge. Phosphates on the first page, it's PO4 with a -3 charge. I crisscross down. I don't need parentheses because I just need a 1, so this is Li3PO4. Ammonium oxide. Ammonium is on our first page, that's NH4 with a +1 charge. Oxide is oxygen with a charge of -2 because it would rather gain 2 electrons than lose 6. I'm going to crisscross down. I'm going to need parentheses because I need 2 ammoniums. So I put ammonium in parentheses and then my 2 and O. Barium is in group 2A, so it's going to lose its 2 valence electrons and get a charge of +2. Hydroxide's on our front page, it's OH with a charge of -1. I crisscross down my numbers. I have to have parentheses because I want 2 of these hydroxides. So my formula is BaOH in parentheses, a 2. Calcium cyanide. Calcium's in group 2A, so it can lose 2 or gain 6. It's going to lose 2, so it gets a charge of positive 2. Cyanide's on the first page. It's Cn with a charge of negative 1. I crisscross down. I'm going to need parentheses because I want 2 cyanides. So this is Ca, Cn in parentheses, outside my parentheses 2. Next I have sodium chlorite. Sodium's in group 1A, so it can either lose 1 or gain 7. It's going to lose 1, so it has a charge of plus 1. Chlorate is on our first page. It's ClO3 with a negative 1 charge. I crisscross down my 1s, and remember I don't write 1s, so this is just NaClO3. And then we have potassium sulfate. Potassium's in group 1A, so it can either lose 1 or gain 7. It's going to lose 1, so it has a charge of plus 1. Sulfate's on our first page. It's SO4 with a charge of negative 2. I crisscross down my numbers. I don't write 1s, so this is just going to be K2SO4. Number 10. In question 3, you were asked the difference between calcium nitride and calcium nitrate. Now write the formula for each of them. So calcium nitride. Calcium is Ca. It can either lose 2 or gain 6. It's going to lose 2. Nitride is nitrogen. IDE ending means you look on the periodic table, so that's nitrogen. It is in group 5A, so it can lose 5 or gain 3. It's going to gain 3. I'm going to crisscross down. And so I have Ca3N2. Calcium nitrate, right, it's still Ca, and it's still going to have a charge of positive 2 because it would rather lose its 2 than gain 6. Nitrate's on the front page. That's NO3 with a negative 1 charge. I crisscross down. Notice I am going to need parentheses because I need 2 of these nitrates. So my formula is CaNO3 in parentheses, a 2. Information formulas for acids. Acids are compounds that contain positive hydrogen ions bonded to a negative ion. For example, carbonic acid is formed when the carbonate ion bonds with 2 hydrogen ions to give H2CO3. Other common acids are listed below: hydrochloric acid, sulfuric acid, nitric acid, acetic acid. Now, just on a side note, I will never call acids by their acid name. I will call hydrochloric acid hydrogen chloride because you can get its formula by writing its formula like it's an ionic compound. Sulfuric acid will be hydrogen sulfide, hydrogen sulfate. Nitric acid will be hydrogen nitrate. And acetic acid will be hydrogen acetate. Okay, so I'm never going to call them by their acid names. Question number 11. Why do carbonic and sulfuric acid require 2 hydrogen ions to bond, but hydrochloric acid and nitric acid only have 1? Right? Because that goes back to why I call them hydrogen carbonate. Hydrogen has a charge of plus 1. Carbonate is CO3 with a charge of negative 2. So I crisscross down, right? And I have to be H2CO3. For sulfuric acid, hydrogen, sulfate, SO4 negative 2, 2, 1, it has to be H2SO4. With hydrochloric acid, it's hydrogen, and chloride has a charge of -1, so I crisscross down my 1s and I just get HCl. Okay, and hydrogen and nitrate, which is NO3 -1, I crisscross down my 1s and I just get HNO3. So carbonate and sulfate both have a -2 charge and therefore require 2 hydrogen ions, each having a +1 charge, so that overall the formulas will be neutral. Phosphoric acid is made from the phosphate ion and hydrogen ions. Write the formula for phosphoric acid. So again, I wouldn't call it phosphoric acid, I would call it hydrogen phosphate. I might kind of say AKA, okay, phosphoric acid, but I'm going to call it hydrogen phosphate. So hydrogen has a charge of +1 as an ionic compound, or an ion. Phosphate is PO4 with a charge of -3. I crisscross down. And again, I don't need to write that 1, so it's going to be H3PO4. So H3PO4, 3 hydrogen ions are needed because phosphate has a -3 charge. So I know that that was a long video, but hopefully it helps you understand ionic compounds. We are going to talk about this more in our notes, but this should get you already thinking about it and starting to understand it. Have a great day. Talk to you tomorrow.